Hi everyone, myself Dr. Lakshmi Prasad, working as an associate professor in the Department of Data Science in Institute of Aeronautical Engineering, Hyderabad. So in this video, I'm going to discuss about a hypothesis testing. So when it comes to the introduction of this hypothesis testing, so normally this kind of testing is going to be performed uh, in statistical inference purpose. So this should be consists of various methods, so which should be able to make the inferences or generalization about the population. So example is that the test of hypothesis. So normally for implementing this hypothesis, we need a population and then random sample. So you already in previous video covered about what should be the statistical inference, right? So in this statistical inference, so we are going to have so many kinds of methods. So we should be able to make so many inferences or generalization about the population, right? So in order to test that, we have a test of hypothesis here. For testing this, we need a population and then random sample. So what are the symbols that are going to be need for implementing this testing? So for that, we're going to have H naught, what is going to be represented it as null hypothesis here, and H1, so what we call it as a alternative hypothesis, and the Greek beta, so this is the beta letter, which should be a Greek letter, so which should be the probability of committing a type 2 error, and alpha, which should be a Greek letter alpha. So then it should be able to denote the probability of committing a type 1 error, and which is also going to be known as a level of significance. And Z and sigma, so it should be a Greek letter here, so which means the means, the variance, and sigma x should be treated as the standard deviation of the sampling distribution of the mean, and mu is the Greek letter, which should be the mean of normal population, and n is the sample size, and x bar should be the sample mean, and t distribution, so it should be a case where the population standard deviation is unknown, and s is the standard deviation. So these are the symbols that are going to be used for implementing this hypothesis testing. Okay, so initially you have need H naught, so what we call it as the null hypothesis, and H1 is this what we call it as an alternative hypothesis. So once you define this null and H1, so we have symbols like mu, already I covered in previous video, like mean, and sigma should be the variance, and sigma x should be the standard deviation, and x bar should be the sample mean, and n should be the sample size. Initially you have to know all this, right? And what type of errors we're going to get here, like type 1 and type 2. Okay, so this should be the hypothesis, and these are the values that have to be known, and this should be this types of errors what we can able to get it here. So what should be the statistical hypothesis? So statistical hypothesis is an assertion, or it may be conjecture concerning one or more populations. So normally we're going to treat only normally single population here, right? So if we're going to maintain so many multiple populations or more number of populations, then this statistical hypothesis comes into picture here. So in this, what I'm going to do, so assumption or a statement is going to be defined, so which may or may not be true, connecting one or more population. So there are two types of statistical hypothesis, like null hypothesis and alternative hypothesis. So just know what I said, right? So for any kind of problem, so initially you have to think there may be a solution or may not be a solution. So this to an assumption, right? So this assumption is going to be done in hypothesis. So initially null hypothesis, and that is alternate hypothesis. So if I'm going to consider an alternative hypothesis, so there are again two types like non-directional hypothesis and directional hypothesis. So non-directional hypothesis means that which is going to be asserts one value that is going to be different from another and also called as two-side hypothesis. And directional hypothesis should be also an assertion that one measure is less than the other measure of the similar nature, also called as one-side hypothesis. Okay, so non-directional should be considered as two-side hypothesis, and directional hypothesis will be treated as one-side hypothesis. So like this, we're going to be consider different types of hypothesis, whether that should become two-way direction or one-way direction. We have to be considered. So the examples of statistical hypothesis takes an example like, suppose I'm going to take a statement like average annual income of all families in the city is this. Okay, so what should be there should be the null hypothesis. What I'm going to be considered is alternatives. That means that the average annual income of all the families in the city is not some 36,000 PHP. So this should be null hypothesis, and this should be alternative hypothesis. So this is one thing, and so I'm taking another kind of statement like there is no significant difference between average life of brand A bulbs and that of brand B bulbs. Like then what should be the alternative thing is that there is a significant difference between the average life of brand B bulbs should be and that of the brand B bulbs. So there should be no difference, and there should be a significant difference. So I'm going to consider this as well. And next one, I'm going to consider the proportion of Metro Melina College students who prefer the taste of Pepsi Cola like this is this. So similarly, the same thing should be less than that of this p value, and this should be the null, and this should be the alternate. And similarly, the proportion of TV viewers whose watch talk can shows 9 to 10 in the evening is the same on Wednesday and Fridays. But the alternative is that should be greater than that of this. So the proportion of TV viewers who watch talk shows from 9 to 10 in the evening should be greater than that. So these are some of the examples of statistical hypothesis for any kind of problem. Then we're going to see what kind of errors I can able to get in the statistical inference. So finally, have four possibilities on the acceptance and rejections of H naught. So what kind of consequences operations is going to become in testing hypothesis? We'll see now. So I'm taking the decisions as accept and reject, and here true and H naught is true and H1 is false. Okay, so for this acceptance, if the H naught, what I'm the assumption I'm taking, if it is true, then it should be considered as the correct decision. If it is false, then I can able to get the type 2 error, which is going to be denoted by beta here. So similarly, in this, if H naught is going to be assumption is false initially, but it comes true, then what will happen? I can able to get type 1 error, which is going to be denoted by alpha here. And similarly, whatever the assumption I'm taking as false and result is also going to be false, then the decision what I'm taking should be correct. So initially H naught assumption is true. If it is also true, then I can able to get correct decision. So similarly, if it is false, H naught is false assumption, I can also get the initial correct decision. So initial assumption is true, but output is false, then it should be type 2 error. If initial assumption is false, if I'm going to get true, then it should be type 1 error. So for implementing this testing of hypothesis, so what are the elements you have to be considered? We'll see now. So for that, initially you have to be CH now, which should be the null hypothesis. And the second one, you have to be considered the alternative hypothesis, so it should be represented as H1. And then test statistic, so it should be a sample statistic which is going to be decide so whether this hypothesis is going to be reject or accept or not. And finally, how to see this rejection area, how much of this will have to be considered or not. So based on the rejection, you have to calculate this test statistic. And finally, how to make the conclusion. So whether this assumption what I have to be considered is going to be fill on rejection area or not, we have to see. And what are the steps we have to be follow for performing the hypothesis testing here? So for that, initially formulate H naught and H1 and then specify the level of significance and choose the appropriate test statistic and establish the critical region and compute for the value of the test statistic and make a decision, and if possible then draw the conclusion here. So initially I told that the assumption is going to be considered, and this assumption is going to be either null hypothesis or it may be comes from alternative hypothesis. So then specify the level of significance here and choose the appropriate test statistic. Then establish the critical region and compute the value of this test statistic test here and make a decision finally. So whether you have to be drawn the conclusion or not. So what should be the level of significance? So this one is going to be specify the probability of committing a type 1 error, so which is popularly known as level of significance. And we can able to determine the critical values, so which is going to be defined in the region of rejection and region of acceptance. So this region of rejection, what we consider it as critical region, and the critical value serves as the basis for either accepting or it may be go for the rejecting the hypothesis. So when alpha is equal to 0.5, what we call it as region of rejection, and if and the region of acceptance should be 0.95. Okay, to specify the probability of committing this type 1 error, so which is known as a level of significance, right? So in this we have to be determine the critical values, so like region of rejection what we called as critical region, and region of acceptance what we have to be considered. And this critical value serves as the basis either for accepting or rejecting the hypothesis. So when the alpha value is 0.05, then it should be treated as region of rejection, and if it is 0.95, then it should be treated as region of acceptance. So there are two types of tests what we are going to be considering here. So one is that one tail test and two tail test. So this what is should be one tail test. So if it is a directional one, then it should be we have to call it as a one tail test. If it is H1, If it is non-directional, then it should be treated as a two-tailed test. So what should be the one-tailed test? And if the region of rejection is going to be lies entirely on one end of the distribution, then it should be considered as one-tailed test. Suppose this rejection regions involve some of the critical regions which is going to be split into two equal parts. Okay, then it should be considered as a two-tailed test. Then in two-tailed test, what I'm going to do is that the value of parameter is being hypothesized. So the mathematical formulation is that, so normally we're going to consider three cases. If the H1 is should be the greater than that, the region, so the area of the rejection is placed entirely in the right tail of the distribution. And similarly, if this H1 is less than that, then we have the region of rejection should be left tail and not equal to. So that means both the tails contain equal areas serves as the critical regions. So these are the two uh, types of tests what we can able to perform on this hypothesis testing. So one tail test, so it should be where the region of rejection lies entirely in one end of the distribution, and two tail test, what we call this, it should be involves the critical region where you can able to split into two equal parts placed in each of the distribution. So greater than, so if H1 is greater than that, the area of rejection should be placed entirely, and if it is less than, then the region of rejection should be left tail. And not equal to means so both the tails contain equal areas serves as the critical region. So example, what form of hypothesis should be used here? So for that, suppose if theta be the average age of heart attack means, then how much it is, like H0 and H1. So if H1 is greater than 0 and less than 0 equal to 0, we have to be considered. Suppose if I'm going to see the graph, I'm going to get the critical value and alpha values like this. So what will happen after constructing this? So the region of this entire part should be treated as the region of acceptance, and the part which should be right side of the right tail, what we call. So how much of a region of rejection you can able to construct. Okay. So similarly, if the our z value is minus and alpha value is this one, then how much area of rejection is going to be taken is to be considered when I move to the left side. And the region what I'm going to show here, that should be the region of rejection, how much it is. So when it comes to the two-tailed test, so here what I'm going to do is, so I'm going to consider the plus or values or z values. So 1.96 and minus 1.96 and alpha value is this one. So the region of rejection, right? So what should be like in between this? So that should be the region of acceptance. Okay. So what will happen here? So this should be two-tailed test where you can able to consider the uh, two limits. So then critical regions in testing hypothesis. So rejecting H naught. So what are the significance level? So for that, the whatever the value I'm computing, so if it is greater than the critical value, so that is the case in one tail as well as the two tail. And next one. So if the what is the under case of getting the rejection here? So the computed value of z should be less than the negative critical value. Then it should be in one tail and two tail as well. So whatever the value I'm computing that, so that is the value of critical. So that should be less than the critical negative critical value. Then it should be rejecting the cases of the H naught. So The steps what I define initially, so that thing you have to be formulate here. So first formulate H0 and H1, and then specify the level of significance and choose the appropriate test statistic what you have to be considered, and establish the critical region and compute the value of test statistic test, and make a decision that whether you have to be uh, either accepting the hypothesis or rejecting the hypothesis. So initially, so what I said, so initially define this H0 and H1, right? So once you define this H0 and H1, so then I have to consider the level of significance. So in that, what we have to be, we have to be consider the region of rejection and region of acceptance. So for this, we have to perform two types of test. What I said here, that should be one tail test and then two tail test. So the value what I'm getting, so that should be matches these cases, like greater than or less than, or it may be not equal to. So these are the steps what I followed initially. And so finally, for the this normal distributing the data, so one sample test, so where if I'm going to consider the single population, then standard deviation is to be like variance is to be considered here. And for in case of two sample test for the one population, then have to be known sigma 1 square and sigma 2 square is going to be known, and or it may be a chance of getting unknown also, and then finally have to see the sample test, right? So these are the ways of implementing this test hypothesis. Thank you.
Like, share, and subscribe. Hit the bell icon for more updates.